problem. It is also worthwhile to conduct the other tests for that card as detailed in the ROMP test specification and those in the system test specification. This will ensure that a card with more than one failed component will not be returned to service. After successful completion of these tests, the card can be returned to spares as a properly working card and marked good. To test the auctioneering differential amplifier circuit of the lift and gripper regulation circuitry cards, follow steps 1 through 3 as outlined in paragraph A3.2.1.6.2 of the ROMP test specification. Record the data as requested on the data sheet of paragraph A3.2.1.8. If any measurement does not fall within the required tolerances, this is an indication that a problem exists in the auctioneering amplifier circuitry of the regulation card. This circuitry is composed of transistors Q1 through Q8 and their associated biasing and regulation circuitry. Each of these transistors is actually a dual transistor type that becomes a differential amplifier when combined with its associated circuitry. The reference voltage V sub ref developed by the reference circuit is fed to the non-inverting input of each differential amplifier. This voltage should be measured at the input to the differential amplifier under test. The inverted input of the differential amplifier is where the current sampled from the mechanism coils are fed. The difference between the reference voltage and the voltage generated by the coil current flow to the transistor base resistor is obtained from the collector of the inverting input transistor. Thus, the greater the difference between the input voltages, the more negative the output from the collector. Since all the collectors from the outputs of the inverting input transistors are tied together through diodes to a common line, the output of the most negative differential amplifier reverse biases all the other diodes. The most negative output is then the only one fed to the auctioneering amplifier circuit for amplification. Resistors R26 through R33 establish the nearly constant current through the dual transistors. Resistors R9 through R16 are the input resistors to the inverting input of the differential amplifiers. Diodes CR9 through CR16 are the auctioneering diodes which are turned on or off by the most negative output of the auctioneering bus. Zener diodes CR1 through CR8 are protection diodes that limit the value of the input voltage to the differential amplifiers. Resistors R1 through R8 are the feedback resistors for each differential amplifier respectively. Resistors R18 through R25 are the load resistors for the inverting input transistor. R17 is the common load resistor which, along with the Zener diode CR17, establishes the constant reference voltage to each of the non-inverting inputs of the differential amplifiers. With this information, any defective component in this circuit can be isolated via standard transistor circuit techniques using the test module controls and switches in test A3.2.1.6.2. After isolation and repair of the defective component, the board should be retested to verify correction of the problem. Following successful completion of the tests, it should be labeled as good and returned to spares. To test the operation of the E sub-sat detector and the ripple detector circuits of the lift and gripper regulation cards, follow the procedure as outlined in paragraph A3.2.1.6.3 of the ROMP test specification. The measured values obtained from this procedure should be recorded on the appropriate data sheet of paragraph A3.2.1.8. If any discrepancies are noted between the measured voltages and those indicated on the data sheet, A problem probably exists in the E sub sat detector circuitry or the ripple detector circuitry. In troubleshooting the E sub sat circuitry, it is necessary to understand that this circuit is first triggered by the voltage error signal V sub ERR, which comes from the reference circuitry on the same card. V sub ERR saturates positive or negative whenever a request for change in current to the coils is received. If the coil current command is to go from low to high, V sub ERR would saturate in the positive direction. If the call is for current to go from high to low, the error signal V sub ERR saturates in the negative direction. As the coil current approaches the requested level, V sub ERR is reduced. If V sub ERR remains in a saturated state for some time, this indicates that the coil current is not being regulated properly. The E sub sat, or saturated error detector circuit, detects the presence of the error signal voltage V sub ERR in its saturated state beyond its normal limits and generates the saturated error V sub ES. V sub ES is then supplied to the regulation failure detector card. If V sub ES goes high, approximately plus 23 volts, a regulation problem is indicated. If V sub ES is 0 volts, normal operation is occurring. The E sub sat detector circuitry that causes the aforementioned action is composed of transistors Q12, Q13, and Q14 on the regulation card. In normal operation, no sustained error voltage V sub ERR greater than plus 6.2 volts, transistors Q12, Q13, and Q14 are turned on and conducting. This makes the saturated error voltage V sub ES, which is taken from the collector of the transistor Q14, to be near the 0 volt level. This can be measured at TP3 of the board. The proper biasing conditions for transistor Q12 is performed by Zener diode CR28, which provides minus 6.2 volts to the emitter of NPN transistor Q12, and resistor R47, which provides 0 volts to the base of Q12. Zener diode CR27, resistor R46, and resistor R45 form the same function for transistor Q13, providing plus 6.2 volts to the emitter of the PNP transistor. Biasing of NPN transistor Q14 is obtained by current flow through transistor Q13 and resistors R50 and R51. If an error voltage input to transistor Q13 exceeds the plus 6.2 volt level, diode CR22 feeds the error signal to the base of PNP transistor Q13, thus cutting it off. This in turn shuts off transistor Q14, whose collector then goes to plus 23.5 volts, as can be measured at TP3. If the error signal goes more negative than minus 6.2 volts, NPN transistor Q12 is turned off, causing transistors Q13 and Q14 to turn off, again causing plus 23.5 volts to appear at the collector of transistor Q14. Voltage measurements can be made in the circuit points just discussed to isolate a faulty component in this circuitry. After isolation, repairs should be made and the board retested. The board, upon successful passing of the other tests, should be labeled good and returned to the spare card holding area. The ripple detector circuitry of the lift and gripper regulation card is composed primarily of transistor Q15, Zener diode CR50, and diodes CR51, CR32, and capacitors C4 and C5. Together, these components act to sample the ripple of the coil voltage, which is also applied to the circuit. Since transistor Q15 is also normally on via the biasing of resistor R50 and R54, and the conduction current of transistor Q13 in the E sub sat detector circuit, it holds the sample ripple voltage at 0. When transistor Q13 is turned off, transistor Q15 is turned off as well, and the ripple detector is permitted to sample the ripple voltage. A missing phase voltage or a malfunctioning thyristor can be detected by the increased ripple voltage they cause. Capacitor C5 then integrates the input sample coil voltage, and C4 charges through diode CR32 to the coil input voltage. This voltage is then passed on to the failure detector card as the sample ripple voltage V sub rip. This is the voltage that is measured at test point TP4. Using the information just discussed, isolation of any faulty components in the ripple detector circuitry is easily performed. After repair of the faulty component or components, the board should be retested. Return the board to the spares inventory only after it has been fully tested.